Hi, Assalamualaikum and good afternoon. I'm Nur Azira binti Muhammad. My metric number is F18B0114. I'm going to present my final year project topic, which comparison of nutritional composition of mushroom byproduct versus protein body. Oyster mushroom, also known as Pleurotus ostreatus, are popular due to its favorable flavor, taste, and high demand among consumers. Agricultural wastes are high in nutrition cause their disposal difficult to handle, which cause leaching if they are left as compost. They are commonly disposed by incineration, which pollute the environment. To overcome the problem, mushroom waste need to manipulate and modify. The objective of the research is to measure the antioxidant activity of mushroom byproduct using DPPH and MBTS assay, to determine nutrition composition of mushroom byproduct using approximate analysis, to compare antioxidant activity and nutrition composition of mushroom byproduct versus protein body. There are two hypotheses which null, mushroom byproduct has no nutritional composition compared with the protein body. H1, mushroom byproduct has higher nutrition composition compared with the protein body. Method. Both samples were collected from mushroom house, UMK Jeli. They were cleaned and sieved with 500 micrometer before run in triplicate in each analysis to ensure get the accurate result. The approximate analysis were determined using Gerhardt analysis, Sortec 2055, FiberTech 8000, and Ash Oven. For moisture analysis were run in manual method as daily collecting sample. For antioxidant activity, samples were extracted using inclusion method before analyzed using FTS and DPPH assay. The use of graphite prism as for statistical analysis. Result and discussion. Approximate analysis. In graph A, show the lot difference of percentage between both. With protein body was 27.84% and waste was 9.11%. The p-value was 0.02, so it was significant. In graph B, show fat content of protein body was higher than waste, which states protein body was 2.27% and waste was 1.12%. The p-value was 0.04, so it was significant. In graph C, show fiber content in waste was higher than protein body, which 15.33 of waste and 7.39 of protein body. The graph was significant with p-value 0.001. Next, graph D show there's no much difference of percentage value between the sample with higher protein body with 87.67% and waste with 76.97%. The significant value was 0.0003. In graph E, show ash content between both samples was not much different. However, protein body has lower percentage of ash with 6.96% and waste was 8.37%. The significant value was 0.009. And lastly, graph F show percentage of carbohydrate in byproduct has higher than protein body with 89.39% and 62.93% respectively. The significant value of both samples was 0.03. Okay, next, antioxidant analysis in ABTS. According to graph of ascorbic acid standard curve in A, we can observe that concentration for both inhibition ABTS were increased from 173.71 with ST 0.706 to 17.33 in ST 0.52. In first concentration, protein body has 178.2 with standard deviation 0.26 compared to byproduct 174.82, standard deviation 0.07. In second concentration, protein body has 176 0.86 with ST 0.41 and byproduct has 175.737 with ST 0.24. Next, floating body has 181 with ST 0.74 and byproduct has 177.97 with ST 0.13. In Ford's concentration, floating body has higher inhibition of 183.18 in ST 0.53 compared by product 178.19 with ST 0.27. Less concentration show floating body has high inhibition of 185.75 with standard deviation 0.58 compared by product 182.93 with standard deviation 0.48. Thus, it was indicates that floating body has higher antioxidant activity in FATS analysis. Same goes to graph of ascorbic acid in D. We can observe that concentration of inhibition DPPH also will increase from 28.7 in with ST 5.35 to 48.7 with ST 1.6 respectively. In first concentration of DPPH, floating body has 5.3 with ST 0.3 compared to byproduct 3.8 with ST 0.26. In second concentration, floating body has higher inhibition of 7.02 with standard deviation 0.4 compared floating body 4.68 deviation 0.61. Following that, floating body has 7.76 with standard deviation 0.15 compared by product with lower inhibition of 5.83 with standard deviation 0.31. In fourth concentration, byproduct has a lower inhibition of 10.24 standard deviation 0.21 compared to floating body, which has higher inhibition of 12.04 with ST 0.36. In last concentration, byproduct has 10.24 with ST 0.21. However, floating body has value of inhibition of 12.04 in ST 0.36. The result indicate the high result of antioxidant were found in floating body extract. In conclusion, based on proximate result, show the floating body has higher in protein, fat and moisture content. However, byproduct also contain higher fiber, ash and carbohydrate than floating body. Next, antioxidant activity as result previously clearly show the highest antioxidant activity of scavenging 50% was floating body with minus 8014.37 followed by product minus 7184.97 and lastly ascorbic minus 156.94. Same goes to DPPH. The highest antioxidant activity was floating body with 3388.84 followed by product 3357.84 and lowest was ascorbic acid 30.45. So it's conclude the hypothesis H1, which byproduct has higher nutritional composition compared floating body, was acceptance only in fiber, ash and carbohydrate. Overall, compare of both sample, floating body has higher nutritional composition compared to byproduct. Recommendation. Because of mushroom byproduct has higher nutritional composition in fiber and carbohydrate, it can suggest as new correction of food consumption such as dietary food. Furthermore, the composition between floating body and byproduct were not so much different. So, mushroom byproduct maybe can be produced as other product like cracker, cereal and sauce. Finally, this study also can be used as a reference for future study on both of floating body and byproduct. This is my reference and this is appendices of my lab activity. Okay, that's all from me. Thank you.